thanks to everybody to attend this presentation. And today I'll show you our pipeline to implement RDF graph. In other words, how to transform these resources in this. This resource, by the way, is from our archive and correspond to a digital object. So what I show you is the pipeline we use to transform these digital resources into this RDF schema. The tool we are using, first of all, so we are using EasyDB platform to manage all the records for the digital record. 3M mapping tool, mapping memory manager tool to transform and to implement our mapping schema. The mapping template, the semantic reference data model. So this is a standard mapping template used to define the main entities in our knowledge graph, built on top of SIDOC CRM ontology. And for us, I think is one of the most important elements since this mapping template gave us the opportunity to be interoperable with the rest of the world base. The generator policy, which is another XML file meant to implement and generate the URI according to our mapping model. The profile parser tool, which is our Python tool able to harmonize the XML dump from EasyDB into another XML compliant with our mapping template. And then the profile mapper, which is meant to transform XML data into RDF graph. And I'll show you everything later in a demo. How these tools are, let's say, built together. So we have EasyDB, which is our first step in ETLing our data. Data from EasyDB are dumped in a zip file, which consists of some XML records. Then these records are harmonized via our Python tool. Then from these XML record, we use one record as a master into 3M to create the mapping model. Then by using the X3M file, which corresponds to the mapping schema as a source record or master schema, we are transforming then the XML harmonized into RDF ready to be ingested into research space platform. So EasyDB, this is how it looks like the interface when we are dumping the resources from EasyDB. As I said before, EasyDB is meant to manage all the different digital records in our infrastructure and provide also the, let's say, source record for our ETL process. The dataset are exported in one zip file with an XML file, and each XML file is composed by circa 100 records. However, and this is like for us a bit tricky to manage, was because each record is composed on an average between 6,000 and 7,000 lines per code, so per record. And in the case, for example, for the archival object, we had a maximum of roughly 12,000 lines per code, which is a huge number of lines. So everything needs to be harmonized and aligned with at least the mapping schema proposed by and maintained by our mapping model. So how to do that? We implemented our profile parser. It's a Python tool built on top of LXML library. And by using XSLT file, provided transformation and the harmonization of the EasyDB XML dump into another XML file suitable to be mapped into 3M mapping tool. We implemented 5 different XSLT files, which correspond each of them to one of our main entities represented into our mapping schema. So we have E22 buildworks, E53 place, E74 group, E21 person, and E78 collection. Then the third step is represented by 3M mapping. As I said before, so the mapping model is built on on top of one master XML record, which is used as main reference to implement our mapping schema. Our mapping schema are interoperable, and all of them are approved by the special interesting group from SIDOC CRM, the SIG. So we got the certification, I would say. Then to create the RDF URI, according to our Starny schema, we are using the generator policy file, which is uploaded directly into 3M tool. To use the mapping schema we implemented in 3M, everything is exported by this platform with one folder, which consists of the ontologies used to create the mapping model, the generator policy file, and the XTM file meant to transform all the harmonized XM files into RDF graph. Here on the right, you can see the landing page of 3M, where you can define your target ontology by uploading. In our case, we use SIDOC CRM, CRM Dig, FRBR, CPR, and the CRM PC, as well as here on the top, on the bottom right, the source record, which is the master XML record, and the generator policy. But later I'll show you how to build everything. So here an example for example, here we have a snapshot of our master XML record, in this case, which is a buildwork, so E22, and how then is represented in 3M. And then here a snapshot of the X3M output file. So how looks at the end the mapping schema. Then the fourth step is represented by the transformation of our harmonized XML file into RDF. We implemented a dedicated tool in Python built on top of RDF lib library, and transform, basically the goal of this tool is to transform all the XML dumped from EasyDB into RDF graph, ready to be ingested directly into Research Space platform. As argument, took the source XML files, basically the folder where all the XML, the harmonized XML are stored. Then the generator policy meant to create the URI, the RDF URI according to our mapping. The XML mapping schema, so the main mapping schema implemented in 3M, the output path where you can save the resulting RDF file. And since our aim is to be, let's say, more hybrid and interoperable as much as we can, the tool is implemented to be used among our 5 main entities. So by using this argument, the path to UUID, you can choose between one of our 5 main entities, and at the end you'll have the dedicated RDF graph for E78, E22, E74, E21, and E53. A quick remark: in our pipeline, we use only these 5 entities, but this mapping tool can be used also with the other entities. So it's interoperable and multi-mapping, I would say. And this is the resulting snapshot of the resulting RDF graph, how it looks like. And then when we have all the RDF graph materialized, we then ingest everything into the research space platform via Sparkle, or by using the graphical user interface directly from research space. And for the presentation, that's all. Then I have prepared a demo to show the entire pipeline, and of course everything is available on Git. So let's start from the profile parser, which is the first step in our transformation pipeline. Let's say that we have already exported all the files, the source record from EasyDB, and we have these 2 folders with roughly 107 files. So as you can see from now, I have to remove. So as you can see here,
would you zoom in a bit in that terminal? That's barely readable.
So don't know why it doesn't work, but maybe I can try to open with better. Can you see now the screen? Or
it starts to become readable. Yes. Maybe if you can.
Okay. So, but just to give you the idea about the quantity of the information we are gonna to transform. So, and this is just one batch of 5. So, and of course, a lot of them are useless for our mapping model. So we create this profile parser tool, which is meant to transform and to harmonize this source XML file into XML file, but compliant with the Siloc CRM metric. So here we start our process. And then 2 folders are created here. So here we are. Our target file. And as you can see, the XML schema, so the XML file are more readable because we have one entry, so which is just 93 lines, so better than before. And then the next step is to transform the resulting XML file into RDF graph. To do that, we are using our profile mapper, which is this one. It's another Python tool built on top of RDF lib. And here, for example, you can define all the arguments you need to define for the implementation of your RDF graph in a dedicated file or directly into your terminal. So by running this script, we are now creating the RDF graph. So here how they looks. And then, so once we have all of these RDF, say, implemented, we then ingest. Actually, so for simplicity, we are creating one RDF per record, but in our normal pipeline, we are creating biggest and larger RDF graph because otherwise, I mean, it's not manageable to deal with it. But just for the demo, I have so we transform, let's say, record by record, and then at the end we ingest everything in our instance by using these where we are here, the interface from research space or directly via the Sparkle query. And here we are.